Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Emily Greenberg and I'm your host for episode 2 called The Chemistry Behind Forensics. Today I will be discussing the chemistry behind forensic science and crime scene investigation. So if you don't know what forensics are, forensic science is the tests and techniques that are used in the detection of crime. Forensic chemists collect data and evidence from crime scenes and they analyze this evidence to try to figure out the manner of a crime or the suspect, and they can rule out certain manners of death, which can be really helpful in the investigation. Blood and DNA analysis, as well as gunpowder analysis, are all common types of tests that are done in forensics, and I will go into depth about how these different tests are performed. Forensic science is one of the most critical aspects of the criminal justice system because it provides hard evidence in order to convict a criminal, and it can also help to solve crimes. When you're investigating a crime, ruling out certain manners of deaths is really important because this can help to narrow down the search for how someone died, and it can also help figure out whether their death was a homicide or a suicide and really what happened to them. So when it comes to the chemistry behind forensics, there are really two main types of tests that forensic scientists will use in order to analyze their data and in order to analyze evidence that they find at crime scenes. And these two types of tests are called chromatography and spectroscopy. And within each of these categories, there are multiple different types of these tests that can be used for many different reasons and to analyze many different types of evidence. So chromatography is when chemists separate substances into different contents, and this is so that they can determine individual components of a mixture. Sometimes heat is used, and also sometimes substances are dissolved into solvents in order to determine different components of the mixture. This is commonly used when a substance is not pure because it's used to separate mixtures into different components, and these components can later be analyzed. The first type of chromatography that I'm going to be talking about is called thin layer chromatography. So this type of chromatography is a much less complex type of chromatography, and it can be used to analyze inks and dyes of fibers that are left at crime scenes, which can help forensic scientists match a fiber to a specific company. And I think this is really cool because you can figure out the brand of a pen that was used at a crime scene or the brand of a shirt that the suspect was wearing if one piece of thread was left at the crime scene, and this can help to narrow down lists of suspects. And in this type of chromatography, ink or dyes can be tested by using a small drop of the substance, which is then placed at the end of a testing strip, which is usually made of paper. And this testing strip is placed into a solvent. And as the solvent travels, the components that best dissolve in the solvent move further up the testing strip, and the components that are less soluble in the solvent stay further down on testing strip. And this process creates something called a chromatogram, which allows scientists to analyze the solute. Scientists can match chromatograms of known substances to chromatograms of unknown substances. So for example, if a thread that is found at a crime scene is tested using thin layer chromatography, and a shirt that is found in a suspect's house is also tested using thin layer chromatography. These two chromatograms can be compared to each other, and if they match, then that means that the thread that was found at the crime scene is the same as the thread found in the suspect's shirt. And this can help to narrow down suspects and can help to convict people of crimes. So the next type of chromatography that I'm going to be discussing is called gas chromatography, and this is used for volatile liquids, and it's most often used to separate and analyze blood left at a crime scene, and it's also used to discover the contents of a victim or a suspect's blood, which can tell if they had any alcohol or drugs in their system. And this type of chromatography can test to see if an accelerant was used in cases of arson, which would show if a fire was intentional or not. Because if an accelerant is used, then that means that the fire was set intentionally. So, in an investigation, gas chromatography won't really stand alone as the only test being used to test a substance because it can't really confirm the identity of a substance. And because of this, mass spectrometry is used as a detector because it can detect the concentration of the substance being tested. And this provides more of an accurate measure of exactly what is being tested, but still, different types of tests are often used along with gas chromatography. So, the final type of chromatography that I will be talking about today is called high performance liquid chromatography, or HPLC for short. And this is performed by extracting individual components from a solution, and this type of chromatography is often used for non-volatile mixtures that you can't use in gas chromatography. So the detector for this type of chromatography is called an ultraviolet visible spectrometer. And because this is a common detector for substances, this type of chromatography is often used in drug analysis because most pharmaceuticals have UV absorbance, which brings me to a true story of how this type of chromatography was used in a real court case in order to prove someone's innocence. So, Aline Baxter was an Olympic skier who was accused of using methamphetamines after he failed a drug test, but HPLC helped to prove his innocence because it was discovered that the drug in his system was actually just a harmless isomer of methamphetamine. And if this type of chromatography hadn't been used, then he would have been convicted of using methamphetamines while in the Olympics. But instead, it was actually discovered that the isomer of methamphetamine that was found in his system was also a common ingredient in Vicks products that help with congestion. So, because this was discovered, his ban from competing in skiing competitions was overturned. And without this method, it never would have been discovered that he was wrongfully accused, and he would have been banned from competing in skiing competitions over a false claim. So now I'll be moving on to spectroscopy, which is a field of chemistry that involves investigating spectrums that are created when matter interacts with electromagnetic radiation. And in simpler terms, it just involves the splitting of light into different wavelengths. Substances will have certain spectrums which allow this substance to be identified because chemists can compare two spectrums to each other in order to identify an unknown substance. This form of forensic testing is often used to analyze pure substances because when a spectrum for a substance is created, if that substance is a compound or a mixture, the spectrum will be a combination of all of the spectras for the individual components, which makes it hard to identify the substance that is being tested. Certain types of spectroscopy are non destructive and they'll be used before destructive methods. This way, multiple different types of forensic testing methods can be used on one substance. So, the first type of spectroscopy that I'll be discussing is called FTIR. This is a non destructive method, and it occurs when infrared radiation is used to examine skin or clothing of a suspect in order to find evidence like gunpowder residue or minuscule drops of blood. And particles of different substance will absorb rays of light and transmit frequencies that are specific to the substance. So, because of this, when a spectra of an unknown substance is created, a database full of thousands of different spectrums can match the unknown spectra to a known spectra, which can help to identify certain substances. So, the second type of spectroscopy that I will be discussing today is called atomic absorption spectroscopy. And this is a destructive method of spectroscopy, so it'll be used after other methods, other non destructive testing methods are used, and involve the heating of a substance which will break individual bonds. And then these individual molecules can be tested and identified. Radiation in the form of light is then passed through the sample, which forces the atoms of the sample to jump to higher energy states. And because of this, more complex types of substances and compounds can be analyzed. So, this next type of testing isn't technically a type of spectroscopy, but I thought it was interesting enough to talk about, and that is the analysis of fingerprints in criminal investigations. So, when fingerprints are collected, investigators use what's called an alternate light source to find latent, which are invisible fingerprints. And an alternate light source must be used because these fingerprints aren't visible to the human eye without some type of either alternate light source or a powder or a dye stain. And an alternate light source is often a laser or an LED device that will emit a particular wavelength or spectrum of light on the fingerprint, which can allow the fingerprint to become visible and can then be photographed and analyzed by detectives and forensic scientists. And of course, like all other types of evidence that are used in criminal investigations, there are limitations to what kinds of forensic evidence can be used in order to convict someone or to identify an unknown substance. And the Scientific Working Group for the Analysis of Seized Drugs has a list of guidelines that forensic chemists can use regarding the identification of unknown substances. And this is just to provide the most accurate analysis of substances and to make sure that 100% integrity is going into the investigation and that no one is being incorrectly convicted. So, by using chromatography and spectroscopy, forensic chemists can help with the detection of crime, and they can help to narrow down suspects, and they can help provide evidence for court cases, among many other important things that are involved in the criminal justice system. And by using chemistry, forensic scientists can do all of these great things in order to help bring people to justice. So I personally had a great time researching and speaking about this topic because true crime has been something that has interested me for a very long time. And I think that this topic is just so important because it helps to solve crimes and it can also help to bring justice to criminals and to victims. Um, it's also very interesting to see how far forensic scientists have come in the past century because now we can discover so many different things about a crime just by looking at small particles that are found at a crime scene. And I'm hoping that one day I can become a forensic scientist because learning about all of these things that forensic scientists do has really captivated me, and I really just want to learn more about these different types of tests that are used in order to analyze evidence. And I just really enjoyed researching this topic so much. And it's actually ironic because what really got me into forensic science was listening to true crime podcasts, and now I'm able to talk about the science that goes into the investigations of the real cases and the real stories that I hear about on these podcasts. And I really just hope that I can continue to do research on this topic and I can continue to learn more about forensics and the chemistry behind forensics. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.